In this video, we'll be using our knowledge of trigonometry in order to solve word problems. So let's read through this first example together. You are hiking near a canyon. While standing at point A, you measure an angle of 90 degrees between points B and C. You then walk 2 miles to point B and measure an angle of 76 degrees between points A and C. If points A and C are across the canyon from each other, how wide is the canyon between points A and C? So what I'm noticing is I have point A and then points B and C. And points A and C are across the canyon from each other. So let's say that we have A and C. And we know that we're walking to point B, so point B's got to be somewhere over here probably. So what we notice is that if we're standing at point A, the measure between B and C is 90 degrees. So what that's telling us is if we're standing at A and we're measuring the angle between these two, this is a 90-degree angle. Then it's saying we walked 2 miles to point B, and then the angle between A and C is 76 degrees. So just by reading that little bit of information, we were able to draw two angles, the angles between B and C and the angle between A and C. And then we were able to label that side length of 2 miles. And then it says, how wide is the canyon between points A and C? So I'm going to label that with an X because that's the unknown value that I'm ultimately looking for. What is this length right here? Because it's representing the distance across the canyon. So here what I notice is I've got a couple of different pieces of information. First, I notice that I am given my angle, which is 76 degrees. So that's going to be my angle of reference. I then notice that I don't have the hypotenuse or the opposite leg, but I am looking for that opposite leg. And I notice that I have the length of the adjacent leg. So here, because I have this right triangle and because I know one of the other angles, I can start to pick up on the different details that I have. And I know that I'm looking for the opposite, but I have the adjacent. So if I am looking for the opposite and have the adjacent, I need to think through my 3 trigonometric functions that are widely used when we calculate. So I think of SO, CA, TOA. And what I notice is that the only one of these that uses both opposite and adjacent is tangent. So what I'm going to be using here is I'm going to be using the tangent function to help me solve for this missing length, how wide it is across from the canyon. So I'm going to take tangent of theta, or my angle, is equal to the opposite leg over the adjacent leg. So here I can take tangent of my angle, which in this case is 76 degrees, is equal to my opposite leg, which is x, divided by my adjacent leg, which is this 2 miles. Then from here, I can solve this. I'm going to turn it into a fraction so that I can use cross multiplication. So I can do fraction equals fraction and do numerator times other denominator. So I can do tangent of 76 times 2 is equal to 1 times x. So now if I take my calculator and I calculate what tangent of 76 is, I can do tangent of 76 close parenthesis, then times 2. I find that I get 8.02 is equal to 1x. Then you can divide by 1 if you need to, but x is equal to 8.02. So what this is telling me is that in this situation, the distance across the canyon is going to be 8.02 miles. Now, as we tackle trigonometry word problems, we're going to encounter 2 other types of angles. We're going to encounter the angle of elevation and the angle of depression. Now, we're going to read about them in the problem, and we're going to have to visualize what they actually mean. So by definition, angle of elevation is saying if you look at a point above you, the angle that your line of sight makes with a line parallel to the ground is called the angle of elevation. Now, how I think of the angle of elevation is I think of I am a person, and I am always looking out. So that's my line parallel to the ground. And when it says my angle of sight, what it means is I'm looking up at some item in some way. So I'm looking up. Now, my angle of elevation is this angle right here. It's how far I had to elevate my eyes up to look at that item. So when something mentions an angle of elevation, it means I'm going to go out from my sight and then angle upwards to actually see that item. So when I'm making my triangle, it's going to look something like this. Now, if we have an angle of depression, it's the same kind of idea, but I'm always looking out as I'm looking outwards sight line, and then I depress my eyes down to look at an item. So I'm going to depress my eyes downwards to look at an item, and this is known as my angle of depression. And then I've got my right angle there. So you can see that for both of these, there's always a line parallel to the ground, and then from there, your eyes either elevate upwards or depress downwards. But when we see these angles discussed in word problems, it might be helpful to actually draw out the picture and what the person is doing so that you can correctly label your angle as you draw your situation. So let's practice an example together. This says a parasailer is attached to a boat with a rope that is 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the ground. So let's pretend that we've got our boat here. There's our boat. And the parasailer is attached to our boat. So there's a rope that is going upward attached to the parasailer that is up in the sky. Now what we know is that we have an angle of elevation from the boat of 72 feet long. Because it's an angle of elevation, we know that we're going to need a line going outwards to represent the sight line parallel to the ground, and then we have to represent the angle of elevation being the way that our eyes elevate upwards. So here, our angle of elevation is going to be this angle right here at 28 degrees. Notice that my eyes are elevating upwards to look at the parasailer from the boat. So here is our triangle. And then from here it says that the parasailer is attached to a boat with a 72-foot long rope. This is our rope that is attached to the parasailer. Now the last detail it gives us is it says that we want to find the parasailer's height above the boat. Well, his height is going to be the straight up distance. So our goal is to find this value right here and find the parasailer's height. So from here, now I have a triangle with at least one side length and one angle, and I need to find another side length. So I'm going to use my trigonometry to help me to solve this problem. So I start off with SO, CA, TOA, and I take a look at the information I have here. Here I have the hypotenuse is what I have, and I'm looking for the opposite side length, opposite of my angle. So because I have opposite and hypotenuse, I'm going to use the sine function. And the sine function is sine of my angle is equal to opposite over hypotenuse. So here I take sine of my angle, which is 28 degrees, is equal to my opposite leg, which is x, over my hypotenuse, which is 72. Then from here, I turn this into a fraction, and then I can use cross multiplication. So I have sine of 28 times 72 is equal to 1x. Sine of 28, close parenthesis, times 72 is equal to 33.80. So what this is telling me is that this parasailer is about 33.80 feet above the boat. Let's take a look at one final example here. It says a man is on top of a cliff and observes a boat at an angle of depression of 30 degrees. So let's draw this. So we have a cliff, we have a man standing, and we have a boat down here in the lake. So let's say there's our boat. And it says the man is observing the boat at an angle of depression of 30 degrees. So remember, angle of depression means it goes outwards, and then depresses down to look at the item. So this is where we depress down, and this is our angle of 30 degrees. It says if the cliff's elevation is 10 feet above the lake, how far apart is the man from the boat? So let's finish drawing our picture here. So we're going to draw our right triangle. And then it says that the cliff's elevation is 10 feet above the lake. Now we're going to include the man's eyesight in there as well. So it's saying this distance is 10 feet. So it's saying this distance has to be 10 feet. And then it's saying that we want to find how far away the man is from the boat. So that's going to be x. This is our distance from the man to the boat. So from here we need to think about which trigonometric function is going to help us solve this triangle. So let's do SOHCAHTOA and then take a look at what we have. Well, here we have the opposite side length and we're looking for the hypotenuse. So as a result, because I have opposite and hypotenuse, I again am going to use the sine function. So sine is going to be opposite over hypotenuse. So here we take sine of 30 degrees is equal to our opposite leg, which is 10, over our hypotenuse, which is x. And then from here, we can set this up by turning it into a fraction, so we can use cross multiplication. If I cross multiply, I end up with sine of 30 times x is equal to 10 times 1, which is 10. Now I want to get x by itself, so I'm going to divide both sides by sine of 30 degrees because that is simply a number. And so x is going to be equal to 10 divided by sine of 30 degrees. So I can take my calculator and take 10 divided by sine of 30, close parenthesis, and I find that my x value is equal to 20 feet. So what this is telling me is that if I'm on a cliff that's 10 feet high with this angle of depression of 30 degrees, that I will be 20 feet away from that boat.